we're going to look at number 5 and number 6. So number 5, it says on the coordinate grid below, trap is a trapezoid. All right, so TRAP is a trapezoid. Trapezoid zoid is congruent to trapezoid trap. Okay, so we're moving to another trapezoid, which is going to be congruent. All right, and it's the vertices are Z, O, I, and D. All right, Z, O, I, and D. That's important. All right, and the vertices is Z, okay, and D have the coordinates 0, comma, -2, and 0, comma, -5. So Z, they show here, right here, all right, that is 0, comma, -2, and D, all right, has 0 and 5, all right. So, and they're asking us, which of the following could be the possible coordinates of vertex I? All right. So again, what's important is we've got trap, all right, those are our vertices of the first one, and zoid, Z-O-I-D, all right, P has to align with D, A has to align with I, R has to align with O, and T has to align with Z. So T and Z, all right, you can see that something has occurred here where, question? So T and Z, I'll highlight those in yellow, okay? These are associated with each other. Then we have D and P, okay? So this could be, to me, it looks like simply a translation, but it could have been multiple moves. And I'm going to tell you that it had to have been multiple moves because if all I did was translate T to Z, all right, if all I did was take, I want to do this in yellow. If I just translated T to Z, we would have been left 3 and down 7, okay? But that means for A, which converts A, converts to I, all right? That's over there. We would be 3/3, all right? So let me just write that. That translation that I assume is going on here is over 3, 1, 2, 3. So x minus 3, and then down. So we go from here down to my Z point. So that is 7, 8, 9. So y minus 9. Okay. Oops. No, that's 5 and 2. So it's y minus 7. Y minus 7. Well, if I did that, right? So I go 1, 2, 3, and then down 7. 1, 2, 3, 4, 5, 6, 7. All right. Whoops. 7 here. Control Z, Control Z. All right. So I'm 2 and -5. So I end up there. Okay. Now I know that for my point A, which now becomes I, the y coordinate would have to be -5. Well, this is the only one that has -5. All the rest of these, that's -0.5, this is -3, this is 1. And again, we know that there's got to be a difference of 3 between T and P, and in this case, Z and D. All right. it's got to be -5. So this has to be our answer. But now what they say is it is -4.5, comma, -5. So I go 1, 2, 3, 4.5. And if you notice, this falls in between. Let me see if I can zoom in on this. Let me see. A falls in between 7 and 8 there, okay? And it is 4.5 to the side, 4.5 to the right of P. So the answer here is going to be, I need to zoom this back out. The answer here is going to be 4.5, -5. All right. The 4.5 is the difference between the P and the A. All right. So anyway, that's what it has to be. And that trapezoid would end up looking like this, and we're 1, 2, 3 there. So it's 1, 2, 3 there. So we essentially have a reflection and a move from that. So we would have reflected over to here and then a translation down. 1, 2, 3, and this goes out 4.5. So we would have reflected across 1.5. Boom. And then down. So, so the answer there is -4.5, -5. All right. This one, focus here. All right. I want to show you guys, this one is really easy. When we talk about rigid transformations or rigid motions, all right. And anytime I say something 3 times in a row, it's something to write down. Anytime we have a rigid transformation, the shapes stay the same. They are congruent. Anytime we have a rigid transformation, the shapes are congruent. Anytime we have a rigid transformation, the shapes stay the same. So if you look at this one and this one, okay, these triangles, this is nothing but a transformation. This is a rigid transformation. So this one right here is correct. That's a rigid transformation. Here, notice that these triangles look about the same size. Now, I can tell you that this is a rotation, okay, which is a rigid transformation, but they haven't changed size. That one is correct. Now on this one right here, this triangle here, okay, is smaller than this one. All right, that's bigger. Notice the sizes change. That is not a rigid transformation. That is a dilation, okay, that is getting larger with a rotation. So that is not a rigid transformation. That one doesn't count. So A and B count. C does not. D is nothing but a reflection. We know that. That's correct, okay? Notice the same size. Here, okay, we probably have some type of rotation, okay? So, and the shapes are the same. That counts. This one, the shapes, this is much larger. This one here is much larger than this one, okay? So that one is eliminated. So 1, 2, 3, 4. Those are the options we would choose, and the ones where the size of the shape changes, they are out. Okay, we eliminate those. That's not a rigid transformation. Rigid transformation. Okay, the shapes are congruent. They are the same size. So A, B, D, and E would be our answers there. Now, okay. So I've done, let's see, I did 1, 2, 3, 4, 5, and 6. All right, I'm going to throw 7 in on this recording. All right, and then we'll take a little break and we'll move to 8. So square ABCD, shown on the graph below, ABCD shown is rotated 90 degrees counterclockwise. All right, so we are rotating counterclockwise 90 degrees. So we're going one quadrant about point A. Point A is right there. All right, to form square A prime, B prime, C prime, and D prime. So we're, instead of us rotating around the origin, okay, the origin would have been right here. We're rotating around point A. All right, so what would happen here is we would create a secondary grid. And let me see if I can do that. Oh my God. So I go from there to there, and I'm going to move that over just slightly, and it's not going to let me be exact. I got to adjust my mouse. I was almost there. Why can't I just move it to the left? So we're rotating around A. Now here's what's important. They're asking us the relationship of the segment AB to A prime B prime. So what's the new relationship going to be? All right. So let's just, since we're rotating around A is going to stay where it is. B is going to change. So what I'm going to do here is I'm going to work with my triangle on B. All right. So I go over here and up here, and I'm going to make this into a triangle. So that's my segment AB. All right. And that's my triangle. Now, what they say is rotate 90 degrees. So I'm going to go from this quadrant here, all right, over to the next quadrant. So I am, let's see, 1, 2, 3, 4. So 1, 2, 3, 4. All right. And then I am up. I go from 4 to 6. So I'm up 2. So now I'm left 2. So 1, 2, right? And now I've got a new triangle. I want to change it to red, and I want to go from this point down to my origin. Okay. And we can see, if I can get this to stop right there, we can see that that line right there, that's a 90-degree rotation of B, okay? That line right there is perpendicular, okay? And it is perpendicular. That is the answer right there. It's perpendicular, so it's not parallel, all right? Parallel would be 180 degrees. We would have come all the way down here, and it wasn't parallel. It's not the same line. That means it would have went 360 degrees or 0. And A and B intersect, but are not perpendicular to each other. Not perpendicular. Well, in this case, we went 90 degrees around A, all right? They do intersect, but they are perpendicular. So that is not correct either. So the answer there is they are perpendicular, and that parallel. So right there, that will be the answer. Okay. And again, you'll have something that looks like this on the quiz. So, or on the assessment. So let's Let's take a little break here. I'm going to stop recording.